And I'm going to talk about tofu. Well, the basic idea behind tofu is to have a tool for editing images and vectors, which is centered around the easy access and modification of the source of said images and vectors. So the tools I'm using to create this application is Racket, which is a variant of Scheme. And well, let's get right into it. This is the main interface for tofu. Here on the right we have a text editor, and on the left we have a visualizer for what we are editing. The way it works is by basically uh, opening a JSON file which is configured in a special way, and we call it a tofu file, and we just parse that file and render it on the visualizer. Here is the interface, and we can open a new file through the menu. We click here on File and Open. It will launch select a banner to select a new file to edit. As we can see, all files are deactivated except for the one that is JSON. Once we open it, we have here the structure of the file, and here we have what we have drawn. As we can see, the file is based around vectors and vertices. We have a list of vectors, which are the things that are going to be drawn over here, and a list of vertices per vector, which are all the dimensions and all the ways it is going to be drawn. So right here we have two C's, and let me walk through the features. Well, first of all, here on the right we have a normal text editor. We can copy, we can cut, we can do Command C. So we have our history. Also, we can edit these values directly and affect the way this information looks over here. So for example, if we take this point right here, which is the end of this first Z, and we change it to 100, which is the double the information, once we save it with Command S or File Save, well, once we do that, we can see immediately the file changing. So now we have an easy way to interpret and to display images just as we are editing them. Here in Edit we have all the normal functions, and well, let's get to the code that allows us to do this. Here on the right we have our main file, which is the one that allows us to set the environment, declare the things that we need, and we require a tofu parser, which is a file that takes the JSON we've created and draws it on the screen. So we start by defining the name of the file we're working on. Then we define a top-level window, which is this window right here, the one that contains both the text editor and the visualizer. Next, well, we have both panel, which will align our views horizontally. And we then add a text editor on the left and a canvas on the right. Here it's very important to see that we overwrite the paint callback of this canvas with draw.tofu file, which receives a file name, which is what we did previously. Then we add the items to the menu bar. Well, we create a menu bar, and then we add the functionality on that menu bar. We have a save file as, we have a save file, and we have open file. Here we define the menus themselves. With the file menu, we have the option to open and save, and we have an edit menu which inherits all the options for editing. Now let's walk through the way we are parsing our file. Well, right here we're doing use of scheme and the way it treats lists in order to parse the file easily. We basically convert the JSON into a hash map, and then we begin to work our way behind that. So the first thing we are going to do is, once we receive the file, we will try to draw it, and if we don't receive a file, we just display a welcome message to the user. So once we read the file, we need to, for each of the vectors in that file, draw them on the screen, which takes us to the draw vector function. The draw vector function basically takes a vector, it converts it to a path, which is an internal structure of scheme that can be drawn, and then draws that path to the visualizer. Afterwards, well, before that, we have this function vector to path, which works in the following way. We create a new path, and the first vertex of the vector is going to be the starting point, and then we just go through the rest of the vertices and use them as the other reference points for drawing our vector. And that's it. Racket is a very powerful tool which allows us to implement a lot of functionality in very small space and with very little code. The lack of side effects and the use of pure functions is a great help in order to avoid mistakes and errors that usually occur with object-oriented programming, but at the same time, being stateless makes it a little bit difficult to interact from the visualizer to the text directly. Well, this has been Tofu. Thank you for watching.